Okay, today we're talking about section 8.1. So that's direct variation or inverse variation. So there are two types of variation, as you can probably tell. There is direct variation, and then there is inverse variation. And we're going to talk about how to find the values and then some applications go along with it. So if we start with this, we're talking about the variation that goes so if we take a body that's falling, okay, and this is time, and this is the speed. So at time 0, speed would be 0. But then as time would increase, your speed would also increase. So that graph would look like this. So time is increasing and speed is increasing. This makes this direct variation. Now let's talk about the next one. The intensity of the light in the sun. Okay, so this is distance, this is intensity. So think about this. If your distance is really close to the sun, it's very, very intense. But then as you move away from it, the intensity goes down. So as distance increases, your intensity decreases. So distance would increase, intensity would decrease. That would make this inverse variation. Okay? Firing an object. All right, so let's say that we had some rockets. So this is height, and this is velocity. So if you had a particular rocket, at time 0, its height would be 0. But then the velocity will be at its greatest amount. So unfortunately for this one, the velocity if I was thinking about this, the velocity will be going down as time goes down. And its height, so as the velocity goes down, its height goes down. So as the velocity goes, let's see here. Let's go this way. As the velocity increases, okay, then its height is going to also increase. So if I think about this thing's going to take off. Its velocity is 0, its height is 0, but as its velocity, right here is its maximum height velocity. So its velocity is going to be up here, and it's going to be going down. But its height is going to be going up. So this particular graph ends up to, so as the velocity, it will go down as the height goes up. So that means this is also an inverse variation. So here's the best of all of them. The way that you get paid, that's the best one. So if I get, hours work and pay, so my pay is equal to my pay scale, so let's call it K, times the hours worked. So as my hours increase, so do my pay. This is direct variation. As one variable increases, the other variable increases. And that means that your equation is y is equal to kx. Now, we did this a long time ago. We worked with direct variation when you were in Algebra 1, but we used it and we looked at it as a linear relationship. Now we're going to start looking at it a little bit differently, but the same things, it still applies. So now, if we talk about the rate and the time of a trip, okay, so let's see. If your speed is fast, if your speed is great, then the amount of time you take on a trip goes down. So fast speed, less time. So this is time, this is rate. So as your rate is, as your time is increasing, your rate, how much time is going down. So if you go slow, more time. If you go fast, less time. So the variation will be inverse. As one variable increases, the other variable decreases. And that ends up to y is equal to k divided by x, which this may be the first time you've seen this. So the amount of time spent studying and the grade that you expect. So if you spend more time studying, you expect your grade to go up. So that would be direct. The amount of oranges that fit into a box and the size of the box. So if you have a lot of oranges and your size is increasing, so can't you split a lot of oranges in a big box? And couldn't you put a lot less oranges in a smaller box? So this is direct. Okay, so the smaller the box, the less the oranges. And now this one, the amount of oranges to fit in the box and their circumference. So oranges, so let's this is the size of the orange, and this is how much you can put in a box. So if the size gets bigger, the amount that you can put in the box is less. As the size gets down, you can put more in the box. So these two are going opposite, so this is inverse variation. All right, now to do this, finding the exact value. So as if x varies directly with y, so y is equal to k times x. Now this is important that we remember and read this carefully. Write a function to figure out what y is when x is 5. So first thing I do is I start off with this particular, I start off with this. I'll bring this particular, here's how I do these things. So the first thing I do is I start off with my general formula is y is equal to kx. Now I'm going to substitute these numbers in here. 6 is equal to k times 3. I divide both sides by 3. 2 is k. So I found the value of k. Now to rewrite the equation, y is equal to 2x, which is this. And I'm going to substitute that 5 in here for the x. So y is equal to 10. Let's look at the next one. Find the exact values of variation when x varies inversely to y. So y is equal to k divided by x. Now for this one, I'm going to once again follow that exact same pattern, which is what we have here. So I'm going to follow that same pattern. I'm going to do the same thing. So 6 is equal to k divided by 3. Multiply everything by 3. 18 is k. Now I'm going to put the 5 in there for the x. So there I go. All right, now it's really important that I remember those things, but I do all these problems exactly the same way, following those 3 steps. It makes it a lot easier for me. And I'm just depends on which one, if it's inverse or direct, but how I write it. Okay, the paint needed to cover a fence varies directly with the area of that fence. So the area, now again, I'm following what I got from last one. Area is equal to k times the amount of paint. If 3 gallons of paint are needed to be able to cover the fence, how many gallons would I need to cover 240, sorry. So 3 gallons, so that's the amount of paint. 150, 105 is the area. Divide both sides by 3. So I believe that is 105. I believe that's 35. So A is equal to 35P. I'm told surface area, so 240 is equal to 35P. Divide both sides by 35. And I get 6.857, which is really 7 gallons. You can't have 857 of a gallon of paint. So I really need 7 gallons here. Okay, the amount of time it takes to complete a trip varies inversely to the speed. Okay, so the amount of time it takes to do it, so speed is equal to k over time. If the trip takes 10 minutes and we travel 45 feet per second, so I'm going to solve this. So k is 450. So s is equal to 450 over t. Okay, what happens if I go 70 feet per minute? All right, I'm going to make this into a fraction and then cross multiply. So I end up with 70t is equal to 450. Divide both sides by 70. So now I take 450 and divide it by 70. I end up with 6.43 minutes. Okay. So that's it. And now the next. Okay. So that's it for today. Your assignment is there on Canvas for you guys to do. Hope to see you guys back soon.